Hello everyone, in today's videos, we are going to talk about the new update IPAdapter version 2 for animation workflow in more detailed way. We are going to demonstrate different way of making our workflows with various settings for our characters in IPAdapter and the backgrounds using IPAdapter as well. There's a different way in IPAdapter that we can make backgrounds to be dramatic styles or steady styles, but natural motions movement using animated motions model that is also collaborating with the control net. Now, there's no one correct way to do in Comfy UI for animation. It is all about the motions movement, how you want it to present. You can make your style very steady and little movement on the background or using very dramatic styles, like this big sea wave of water rushing onto the screen. Some asked last week in the comment section, why don't we just use an image as the background and need IP adapter or any custom nodes for making consistency background? Well, there's no textbook answer for Comfy UI, and this is not the way to go with generative AI. Plus, if you just want an image background and stick it on the back and think this is consistency, then you can just use a video editor, paste it on a video. This way you don't even need generative AI and computing all these workflows running with multiple AI models, right? So, let's get started. So this workflow has been updated for the IPAdapter version 2. Here, we have the IPA characters and background IPAdapter groups, mainly for styling our characters and backgrounds. You can do this for multiple characters as well. Right now, in this workflow, from what I've tested so far, using the IPAdapter Advanced is more stable than using other IPAdapter custom nodes to load the reference image into the model's data. As you can see, we have the IP adapter loader. This is the first unified loader that connects with our Stable Diffusion models data coming from our loader groups that we've defined the checkpoint models, LoRa's, etc. We then pass that data to these IP adapter groups. We have the first connection with the IP adapter unified loader, and then it processes the first IP adapter for our character image frames. In this case, I've used this white dress fashion demo image for the character's outfit. Then you'll see the second IP adapter below, which we are also going to connect to the unified loader, another one for our second IP adapter advance to process the background image for our video right here. As you can see with this second IP adapter, we have the IP adapter unified loader as well. But the connection for this one is directly connected to the first unified loader. The output from the previous IP adapter is passed into this IP adapter here. So this is the new design of IP adapter version 2, where we don't have to load duplicate IPA models in one workflow again. By passing the IP adapter connections to the second one, we'll have the same model loader and the same generation data flow. This can reduce our memory usage, saving a lot of memory during the workflow execution, and we're also achieving the same effect by using two IPA images and processing each image frame individually here. So you see this background mask that's attached to our attention mask. It's specified for creating the background mask using this image. In this case, I have a street view of an urban city. There will be some movement happening. We're not just going to have everything static and still, right? That wouldn't be very fun or realistic if we want to have motion with people walking, car wheels moving, some smoke coming from the cars, lights on the banners flickering, etc. We need to have a little bit of movement. We don't need a ton of flickering or movement to make it look natural like it's a shot taken from a camera. But realistically, if a camera shot is taken from this view with the main character in the foreground, usually the camera lens would be focusing on the front characters while the background is a little blurry and out of focus. But you'd still be able to see people walking by, cars moving, and so on. That's the effect this new IP adapter workflow is configured for, giving that outcome. It feels like the camera is focusing on the characters walking towards the lens in the foreground and you see a car driving by within those seconds. I kind of like this style. I know some people prefer the completely still static background styles where nothing moves and the lighting doesn't change. But for a situation like this urban city backdrop, we have to be realistic. If it's a real street scene happening, you'd expect things to be moving in the background objects. That's more realistic than just copying and pasting this static background behind the characters. Of course, you could do that. You could just use a video editor to composite a still image behind your characters if you really wanted that look. So why would you need an AI to generate that kind of static scene? That was a point raised in previous discussions where people said they wanted a solid, completely still background behind their dancers. And I was thinking, well, in some situations, sure, you could do that. If you're in a room or backdrop setting that is genuinely very static with no moving objects, then yes, having a totally still shot could work. But imagine if it's an urban city like this, or even a beach scene. The water is never actually going to be frozen solid and static, right? Honestly, if you make a beach background with still non-moving water behind dancers in the foreground, it's not going to look natural or make sense. So rather than going for that super high definition, clearly copy-pasted look with the background just stacked behind the characters, I prefer leveraging generative AI to create realistic motion and movement throughout the whole video. I could just copy and paste a background image behind these characters, but by using generative AI to synthesize subtle, natural movements in the backgrounds, it ends up looking far more realistic and lifelike. That's the effect I'm going for with this workflow. But this workflow is not just utilizing the IP adapter or any generative AI nominally. Rather, we're leveraging AI in a meaningful way. That's how this workflow is designed to operate. I've also updated the segmentation groups here with two options. The first one we're using is our good old SOCO segmenter for identifying objects to match each video. While the background will use an inverted mask, we're staying the same with that portion. The second option we can use for segmentation is the segment prompts. In our case, we have dancers, so you can change the prompt text here, just a simple description like a male, or if you wanted something like an animal, you could put a rabbit, for example. For me, I've put dancers here, and it will do segmentation for that using the same loader as the segmentation models for identifying objects. We also have the same B, which is the grounding Dino modular loader for our grounding Dino models connected here as well. Here's a preview of this, and I did two previews so you can see which method performs better and choose which segmentation approach to use. You can switch between the segmentation methods by connecting the grow mask input. Right now, I'm connecting the Coco segmenter, which is our tried and true method that also worked in previous versions of this workflow. If you want to use the segment prompts via the segment anything custom node, instead, you can connect the output mask from segment anything into the grow mask input node that will apply our segmentation output and input mask using that method. So it's very flexible. I can run test executions, check the previews of both results, and see which one looks better. If the Coco segmenter output is good, I'll reconnect that. If the segment prompts is working better for us, then it's simple to switch to using that instead for segmentation within these groups. That's basically it for this update. I can run two examples using this workflow, one fully applying the IP adapter image output, sending that data into a control net here for masking the backgrounds. We're using the tile model as well, which we had in previous versions, but now with the updated IP adapter performing a bit better. The other example will run the full execution without the tile model, so you can see the difference in the video outcome. Okay, let's try one run using the ControlNet tile model first and aim to keep the background as steady as possible. Obviously, there will be some moving objects since nothing is going to be completely static with the water background I'm using. Here, I'm setting it to 0.55, a bit higher since I need some of the water movement. And in the text prompt, I'll need to add something about the water waves, so let's put water wave at around 0.8 or 0.9 strength. We don't need building this time, so I can remove that word. Okay, everything is set. Let me double check. You'll see the background in the outcome isn't going to look like our previous example, but the character outfit will remain the same. I just want to show how flexible it can be using the IP adapter to create your own styles with different images. One more thing, I'm going to use this Instagram video made by AI as the source video input. I'll set it to 50 image frames and we can check out the result. Okay, the workflow has finished generation, so let's look at the result. This is the first animated group from the first sampling run. As you can see, the water starts flowing in a natural motion rather than having just a single static image in the background with non-moving water. That wouldn't make sense for an animation like this. In this situation, we need the water to be moving, which is why we use the animated motions model to make elements seem lifelike and in motion as much as possible. The second group is the sampler run, where I'm enhancing some more detail on the fashion elements. For this one, I selected the deep fashion segmentation YOLO models in the segmentation group for improved detail enhancement. So you know the white dress is going to look nicer, a little nicer than the first sampling pass. It's also enhancing a bit better with the skin tones and details as well. Then we have the last face swap group, which will be the final step in this process. Let's take a look at the full preview. As you can see, I like having a little bit of movement in the background water waves here. You see some waves coming towards the land, which looks more natural with this kind of subtle motion. Not too much movement though. If you overdo it, it could start to deform the mountains or rocks above the sea, and it won't maintain a consistently high-quality stylized look for the backgrounds. When animating backgrounds, we do need to allow for some motion. Look at the water here. There are some waves coming up, right? And here as well, we have a little wave reaching towards the land side. That's what I would apply if the background is this type of coastal situation. Of course, if you don't have any moving background elements, for example, if the background is just a wall or interior room with no moving objects, then you don't need to use a higher tile control net strength to induce movement. You can set it low as possible to keep things steady. And that's the method I use, combining control net with the IP adapter for adding realistic animated motions here. But I have another example not using the control net tile model. So let's take a look at that. This is another window I had preloaded. I'll disconnect this and simply connect the animate control checkpoint directly to the output as the conditioning for the Stable Diffusion model's data. Here you can see there's more movement happening because the IP adapter is only using the style reference image for background motions. It doesn't treat the IP adapter reference as a static background. In this case, we're not passing it through any control net or tile model for the background. The IP adapter here is just adopting the colorations and noise patterns from the reference image. Based on the noise in this reference, it will process it as a dynamic background style. So in this case, it looks like the characters are walking on a street in some small alleyway of an urban city, behind some buildings on a narrow road. Not a main street like this reference shows. This is how the style turns out when using this approach. For production, I'd say we'll likely want to use a combination of both methods, using Tile Control Net to keep a steady background with some minor movements for the character's steady walking motion. But then if you see the last few seconds where the characters jump back to this position, we'll want to apply this dynamic blurring background style using the IP adapter method for that portion. We could try this out with, say, a beach background instead of an urban one, and you'll see the difference. We'd have this beach scene, but without using control net tile to stabilize it and remove movement, it's solely dependent on the IP adapter digesting the noise from the reference image and using those colorations as the stylized output for the animated backgrounds. Let's run it, and you'll understand what's happening. Okay, the second demo has finished generating. Let's check out the result now. As you can see in the first sampling and the detail enhancement sampling, the water waves have this very dramatic, exaggerated style. You see in the first 2 seconds, the waves are following the hand motions. Let me play a preview of this. See how for the first couple seconds, the waves are reacting and following the hands? Then, once the hands go down, the water crashes in this big dramatic wave pattern, hitting the rocks and splashing up. It has this very dramatic, exaggerated feel without using tile control net to stabilize the background. So it depends. Sometimes if you want the motions to have that more dramatic, amplified style for whatever your video calls for, then this is the approach you'd use. But generally, if you're just looking for normal animations and don't need those extremely exaggerated water motion effects, then you wouldn't want to generate it this way without stabilizing the backgrounds. That's how we achieve those different background motion styles. And of course, we have the character outfit elements here too. For these, I'd recommend using an image editor or something like Canva to remove the background before uploading into the workflow. That way, the IP adapter can focus solely on recreating the outfit style for the character without any distracting background noise or other elements. This allows the IP adapter to hone in on the intended outfit look you want for your character. So this is one method for utilizing IP adapter inferences for stylizing your animation videos, achieving different motion effects that you want to create. You could apply this not just to dancing videos like my YouTube examples, but also to cinematic styles or whatever type of animated sequence you need. Want to create some specific animated effect? Add prompts describing that effect along with stylized IP adapter references, and you can synthesize that cinematic look through this workflow approach. It provides a lot of flexibility for generating all sorts of animated video content in various desired styles. We have the steady background approach like this first example, the more dramatic, exaggerated motion style like the second. The updated version of this workflow will be available to our Patreon supporters so you all can go update to the latest release. Alright, I'll see you all in the next video. Have a great day.